Well, let's do one more example for projectile motion. We're going to watch this clip from Big Buck Bunny. We've watched this before. You can watch the whole movie if you like. It's kind of funny. You're going to watch this from about 540 to 620. The clip should pick up when you link here. You're going to watch it from about 540 to 620. This clip, the bunny, this naive bunny, he's taking out revenge on these bullies, and this one rodent bully he launches, and we want to find out a couple of things about it. Let's just go and watch the clip. Again, 540 to 620, and you can find it by clicking here. All right, now in this clip, the rodent appears to be airborne for about 5 seconds. So if I just watch the clip and count the seconds, I find that he's in the air for about 5 seconds. I'm going to assume an angle for maximum range, that is theta equals 45 degrees. And I want to know a couple of things. I want to find the maximum y and x displacements. I want to know what is y and what is x equal to. All right. So in the course of that, things are made a little easier here because I know the time. I don't need to worry about finding the time, but I don't know what is v naught. I don't know his initial speed, and that's not readily apparent from the clip. But we have this situation. I have this little rodent, whatever he is, and he's following a path that's like this, so very similar to what we had before. And I know that the velocity in the y direction at the top is equal to 0. And further, I know that Vy is equal to V naught y plus AYT. I also know, we'll call this T top. I also know that the time at the top is equal to 1/2 of 5 seconds, which is 2.5 seconds. Right? So I can find my V naught y, or actually I can solve for my V naught. I'm going to go ahead and plug in some things here. I have Vy at the top is equal to 0. V naught y is equal to V naught times the sine of the angle, which is 45 degrees, minus 9.8, because our acceleration is negative, times 2.5 seconds. And then if I solve this for V naught, that's, 9.8 times 2.5 times the sine of, or divided by the sine of 45. That gives me a V naught of 35 meters per second. Now, that's not the y component. Notice that we are solving here for V naught. That's the actual velocity. So, or his actual speed is V naught equal 35 meters per second. And it's at an angle of 45 degrees. All right. Now that's equal to about 75 miles an hour. But he's in the air for a long time, for 5 seconds. That's a long time to be launched. Now that I know the initial velocity, I can find the x displacement. The x displacement, of course, is v naught x times t. It's 1/2 a x t squared. Remember, for all projectile motion problems, ax is equal to 0 because it's not accelerating in that direction. So x is going to be v naught x, which is v naught times the cosine of theta times t. So it's 35 meters per second. Cosine of 45 times t, which is 5 seconds. That's the total time. And that gives me 120 meters. Which is, I think it looks like a little bit more than that in the cartoon, but that's cartoon. Now we can also find the y range. That is, how high does it go? Y is equal to v naught y times t. But notice here that I'm going to use t top because I want to know what is the position at the halfway point, what is the position at the top of the trajectory. Plus 1/2 AYT squared. That's t top again. So this is 35 meters per second. That's times the sine of 45. The sine because it's the y component. 2.5 seconds plus 1/2. I'll write it down here. Times minus 9.8 times 2.5 seconds squared. And that gives me a y range of 30 meters, which again seems fairly reasonable from what we see in the clip. You can go back and judge for yourself. But that's my x range, and then that's my y range. Now, what if I were to ask what was the final speed of the object? Well, you know, you could do this whole thing, and we did this before. Vx is equal to v naught x plus axt. But then you'd say, oh, but ax is equal to 0, so vx is just equal to v naught x. And then you could do a similar thing for vy, v naught y minus, or excuse me, plus ayt. And you would find that vy is just the negative of the v naught y, right? Because he's going up and then coming back down. So where's my picture here? So the speed when he gets here is going to be 35 meters per second. The x component of the velocity will be the same. The y component of the velocity will be the same in magnitude, just opposite in direction. All right, that's the end of chapter 3. But again, there are numerous examples in the homework and in the old test questions that you should go through, and you will need to complete the quiz for this section as well.